All right. So hello, everyone. Welcome to What the Heck is R? An introduction to R by me, Victor Feagins. A little bit about me is I'm a senior statistics and data science major. I've done work in Python and R in the fields of environmental science, engineering, education, and biology. Fun fact about me is I like knitting. As you can see, this is my Zoom background, is knit a bunch of yarn. They are not towels. I'm not in some kind of colorful supply closet. They're yarn. And if you want to know more about me, you can check out my LinkedIn. Professionally, I keep up with it for my various work that I do in internships and employments and things. And so if you want to know a little bit more about me, feel free to check that out. So first off, so we all have varying degrees of what is a programming language, and we all have different ideas of what it is. In layman's term, how I like to see it is it's simply writing instructions for a computer to do stuff, whatever stuff, but you're just telling the computer, here, let me write down the instructions, and the computer reads those instructions and then does something. So in our case, and in R, usually we do stuff with data and data science. So that might mean manipulating data, but it could be a whole bunch of stuff, like hosting a website, renaming a bunch of files, making a video game. It could be all sorts of stuff, but what I like to hear and what you need to know, at least for this workshop, is a programming language simply instructions for a computer to do stuff. Okay. So some examples of languages, right? So some of you may have heard of Python. Python is a very popular programming language that's recently, and it's a general purpose programming language. So you can do all sorts of stuff with it. You can do, of course, data science related things, but a bunch of other things as well, web design, developing games, et cetera, et cetera. A language that you guys may not have heard of is SQL, which is the structured query language. And that language is used for working with databases. And so if you're going to be working at a company where you have data that's not on your local machine, it's like in a big database somewhere, SQL is very important for that. And I know Mufaru here worked a little bit with SQL over the past summer during his internship. So maybe if we have time, we can ask him more about it. R is what we're here about, and it's a statistical programming language. And so I mentioned before, Python is a general purpose programming language. You can use it for all sorts of stuff. But because it's kind of like a master of nothing, Python. You people kind of have developed Python to do different things. R, on the other hand, is was created to do data science, was created for analyzing data, for producing research results and data science. And so that's kind of why we're here, is to learn about R. And that's what it is. It's a statistical programming language. And so if there's any computer science people out in here, I saw some in the chat, you might, well, I'll show some R and you might look at it and think it's really weird and be like, man, if I were to do that in C++, that would be like crazy. But in R, the syntax is relatively simple, I think. So R is a programming language, right? We covered that much. It's a statistical programming language, and it's open source. So what that means is that it's completely free. So you go to the website, you download R, and then you can start working with R, and it's free. You don't have to pay for it. It's similar to how you would pay for like Microsoft Excel, for example. But R is completely free. Anybody can use it. And like I said, R is designed. Its natural environment that it works well in is working with data, particularly tabular data, which means it's data that's organized in rows and columns. So as you might imagine, like an Excel spreadsheet, like that kind of data really works well in R. And what you use it for is answering questions with data. And you can do all sorts of stuff with it, all sorts of stuff, but the essentials are working with tabular data and answering those questions with data. Like I said, you can use all sorts of stuff, and we'll get to that. So access to R. How do you access R? So first you can install it. Okay, you can install it and from their website. And so we'll go quickly sidetrack there. So here I just clicked on the link, and you can see here, download R for Windows, R for Mac, R for Linux. And so you download it for your appropriate computer. as well as RStudio. And some of you may think, what the heck is RStudio? And RStudio is a way to edit R. So we'll go into that a little bit. But again, it's free. And I highly recommend it to download. It's not necessary, but kind of necessary. A lot of people who use R use it, RStudio. The only people I know who don't use RStudio are like people who are like over the age of 50, and when they were introduced to R, RStudio didn't exist. So interacting with R. So this is where I talked about. So you can download R by itself with that first link that we saw and work with it directly. You can use R like that. Or you can use it through RStudio, and you can do the same stuff. It's the same functionality. It's the same code. It just looks a bit prettier and has a bunch of other bells and whistles, so to speak, when you're working with RStudio for R. And I'll kind of do a little bit of comparison, not super in depth, because I never use just regular base, like regular, the default R. I always use it through RStudio. But this is the idea, is that instead of working directly with it, you're working through RStudio. All right, any questions so far? Any questions? Anything I said that might be confusing? All right, I'm gonna drink some water while you guys are thinking. All right, so now let's see some R programming. And this is gonna be a live session, so fingers crossed, nothing breaks. So first off, right, so this is kind of, you just had it installed, you installed it successfully on your computer. I use Windows. Everybody still see the screen, right? You see my windows open up? All right, cool. So we can open up regular R. So this is regular R. This is the default R with no RStudio. And this is what it looks like. It looks kind of old looking because it is old. And you can do the same stuff you can do in regular R. You can do math, you can do R code. We'll get into that later. But this is what regular R looks like. And then RStudio looks like this. So there's a lot more information all at once. So it can be a little bit more scary to look at. But once you realize what it is, it's a lot more useful, I think. And you can see here, it just looks more modern because, well, it is. And it has a bunch of other features that you may not use now, but eventually as you learn more about R, you'll find that they're very useful. And so we'll be doing everything in RStudio and not base R, like the base R editor. Okay, let me close that, pull it up. So here we are in RStudio. Okay, so I had installed it. So here's some of the essential things that you need to know. So there's a lot here, but here's the essential stuff. So here on the left is the console, right? You normally won't be going into the terminal or jobs anytime soon. That's kind of more advanced R things, but the console is where is the bread and butter of R. And this is where you can write R code and, create, do stuff in R is through this console, right? You can type it, hand type each command and do various things with it in the console. On the bottom right is our files. We won't look into that right now, but it's basically my files on my computer. It's just a nice little thing if you're working with multiple files. But first, I have prepared some code for you guys that we'll look at. So I'm just going to use some of RStudio magic to just go directly to where I was working for you guys and cover R basics. All right. Any questions so far? Okay, we're gonna go over R basics. This is the bare minimum of R. Okay. So what I have here on the top left, this window is the where it's my file editor, so to speak. It's where I edit files. So I mentioned before, you can write R code here, right? And get it going. And there it is, right? But you run it line by line and it's not saved anywhere except for like the history in the document. And so when you actually are in the field and you're doing like work that you need to do multiple times or come back to, usually you write it in a script, which is what this is, right? You can write it in a script. There's a bunch of other ways to write R code. but we're going to keep it simple for this workshop. If we have time, I can go over the other ones. So here's a basic R script. So it's basically just text. And then I just tell R, hey, read this text, and then it goes to the console and does whatever I wrote. So let's begin with the basic data types in R. So first off, there's numbers. I'm assuming everyone knows what numbers are. If you don't, you can put in the chats, though I don't know how good of a job I will do explaining what numbers are. But here are numbers. And so in R, you can do math in R, right? You can add 50 plus 10, right? So I'm going to control enter to submit this line of code to the console. And then here you can see it 5 plus 10 equals 60. And you can do, the various mathematical operations, right? 50 times 10 is 500. This is how you do exponents. And yeah, so simple math, arithmetic operations, nothing too complicated there. Here's when it gets a little bit more complicated, because this is what really is the power of programming and kind of using R and other languages. It has to do with functions. So if you remember from algebra, a function is simply, it has an input and it gives an output. So here I have f of x equals y, right? So x in our sense could be anything, and y is whatever the output is. So here, the first function I would like to introduce you to is the round function. So everyone knows what rounding is, right? When a number has a decimal and it's above a 0.5, it'll round up. Oh, excuse me. I am not answering that. Vincent, my little brother's getting upset. You go take it downstairs and answer it. All right, there we go. Little do they know I'm presenting. And that moment will be immortalized forever on YouTube. What am I talking about? Round, the round function. So rounding, everyone knows how rounding works. We can read up on how the round function performs by using this syntax here, question mark round. And we can read about what it does. Yeah, rounds the value to its first argument to thing here. And so we round 50.70. What do you guys think it's going to be? 51. Yes, 51. Right, we round it up. And we can also take the square root of 4 equals 2. The log of 2 is the natural logarithm of 2 is that number. If you know how the natural logarithm works, you know what that number represents. You can also write your own functions. And this is the syntax for it. And syntax just means it's the way that R writes things. So other languages will have different ways to define functions. And this is how R defines functions, is you write the word function, parentheses, whatever you want to call the inputs, brackets, and then whatever you want the function to do inside those brackets. Well, functions can be very complicated, but very simply, this is how you define them. And I wrote a function called cube. So I run the cube function, it saves it into my environment, and we'll go into more about that later. And here I can use my cube function to cube 2. Great. Cubed of 2 is 8. Awesome. All right. Any questions so far? No one's confused about numbers? Okay, we're going to move on to characters. So characters are like words, or they also can be called strings, letters, things like that. And how you define a character is with the quotation marks. So like quote unquote, hello is a character, but it really is a character. So we can see, put in R, it's like, hey, this is hello. You can do dog, cat, necktie, don't do that. You can have spaces in it. You can have the quote, single quote or double quote to define a character. You can have spaces in it. And the difference between the double quote and single quote is simply if you have something that has like an apostrophe or single quote, you may want to define it with double quotes. So those are characters, and you can work with them just like numbers. They have their own set of functions that they work with. So here I'm going to run the function nchar, which stands for number of characters with the word knit. And I run that, I get 4, because there's 4 letters or 4 characters in the word knit. Spaces count as a character. So here I added a space and it's 5. So if you're ever writing a tweet and you don't know how many characters it is, you can open up your R, copy and paste it with the nchar function, and let you know, like, hey, I got enough characters for my tweet. So here's the toUpper function. You can make your function all the capitalized letters, knit, right? They all make them to uppercase, to lowercase, everything's lowercase. So it's hard to tell though, because lowercase k looks very similar to capital K. All right, here's a function I use all the time. It's called the paste function, and basically takes different characters and makes them together, smushes them together. So here, each individual I like knitting turned into I like knitting, just one character. All right, so those are characters, basics. All right, hopefully no one's sleeping yet. We're almost done with the basics, and we get to the more exciting portion. All right, so here we are is logic. Logic values, or logic, the data type. And this is true or false. So true is true and false is false. And this is how you define true, is with all capital true and all capital false. And here you can see we can add true together, because true, it equates to 1. This is how it's represented in R, is the number 1, and false is represented as 0. We add true, we get 2. We add 2 falses, we get 0. You can do some nifty tricks there with logic to help you when you're doing your analysis. So that's just like a fun fact. So basic logic operators. So how you get logic is you ask a question from your numbers, so your words, or your data. You say, is 10 greater than 1? It is true. Yes, it's like a magic 8-ball, like 10 greater than 1. It is. All right, 10 less than 1, false. So there we go. To do equal, to say something is equal to something else. So it is not simply just the one equal sign, it is the double equal sign. In a lot of programming languages, that's how they do it. So is 10 equal to 1? Unfortunately, no, it is false. But 10 not equal to 1, so that exclamation point means not, is true. Right? You can do the same thing with characters, right? Is capital A equal to capital A? Yes, it is. All right, but is capital A equal to lowercase a? False. So because R is case sensitive. So oftentimes when people are coding in R and they want to do, for example, this nchar function, they want to count the number of characters, they might have a typo where they say capital N char and then do knit. And then it's going to throw an error at you. Error in this, could not find function nchar. So it's case sensitive, R is. And it can be annoying, but generally you get used to it and you kind of learn how to deal with it. So a fun fact is character 1 is not equal to number 1. Actually, it is. Forget that. I thought it wouldn't be. But I wonder why. There we go. If I add a space to it, doesn't like it. So here I add the exclamation points to true, and that equals false. So I say not true equals false. So here you can combine logic operators. All right, guys, I hope you're still holding on. We're almost done with the basics, and then we'll work with data. All right, so we have true or false. So this is the or operator. And we won't be going into too much detail here throughout the workshop, but just so that you know it exists, there are logic operators. So if you say true or false, can anyone guess what this might give you? If I say true or false, is it going to be true or is it going to be false? What do you guys think? Put it in the chat. You have 10 seconds. Oh, wait, that's too long. True. Natalie, you are correct. True or false gives you true. And if we say this, then say 10 greater than 1 or 10 less than 1, that's going to give you true because one of these is true and the other one is false. So, or if at least one of the elements is true, it's going to give you true. All right. Now here's and in R is with the I forgot what that symbol is called. The ampersand? No, is that what it's called? I don't remember. If anyone knows, put it in the chat. True and false will give you false. Ampersand, Alex, thank you. And so 10 less than 1 is, and 10 greater than 1 will give you false, because one of them is at least false. All right, so almost done. We're almost done with the basics, guys. So that was the basic data types. There's a couple others that we haven't gone from, but they're all they all come from these four. These three is the numbers, characters, and logic. Those are the three kind of main data types that go through everything. And so vectors are a collection of items. So here you can see I have C, which stands for concatenate, and it's a way to combine various numbers together. So if I run this piece of code, and you can see here that it's just ran it all together, concatenated together. And so one really cool thing about vectors is that you can run a function and it runs on each individual item in the function. So here I'm going to run the round on this vector, and it's going to round each one. 10.6 got rounded to 11, 50.4 got rounded to 50, 30.8 got rounded to 31. So vectors are extremely handy. That's when you're working with data, you're really working with vectors almost 90% of the time. So here we're going to try the same thing with characters. So I'm going to run the toUpper function on these vector of characters, and you can see that every single one of them became uppercase. All right, so now let's talk about assignment. So this is usually what you'll be doing all the time, is assignment of vectors. So far we've just been kind of showcasing what the data types are, but this is really like what you want to do. So here we're going to save. So we have this vector before. So if you notice here, we have the vector here and we have the vector here. And so I repeated this code here, and that's not efficient. In programming, you don't want to repeat code. You want it to you want to reuse things. And so here I have this vector, and I can round this vector and I get the same results. And there we go, 11, 50, 31. And you can see here, this is where the environment comes in. So you can hear on the top right, you can see that numvec is the name of the variable, and what's in numvec is this vector that we created. So very handy to keep track of what's in your environment. So now let's try pets. So we got cats, dogs, turtles, horses. We'll put that all in a vector, and you can see here in the environment, that's where it is. And we're going to see toUpper. It's going to make everything uppercase: cats, dogs, turtles, horses, you know, the typical pets that people own. All right, so now we have this other vector called names: Jimmy, Carl, Eric, Sarah. And I'm going to use my favorite character function, paste, and do something pretty neat. So here I got names, comma, likes, comma, pets. So what do you guys think it's going to do? So I have a vector here and I have a vector here, and I have not a vector here. I just have a regular character there. Well, while you guys are pondering that, I'll just say it. So what'll happen, combine them? Yes, it will combine them. Let's see here. Jimmy likes cats, Carl likes dogs, and Eric likes turtles. Sarah likes horses. So it combined them. So it matched Jimmy and cats, and then a likes in between. And Carl likes dogs, Eric likes turtles, Sarah likes horses. So very neat. You'll be taking, when you become an advanced R user, you take advantage of that kind of behavior all the time. Not even advanced. It's like basic. That's like how you do stuff. That's how you do stuff. Is you take advantage of functions that work over each element. All right. So now let's talk about indexing vectors, right? So we have these vectors, names, numvec, and pets, and we can see how long they are with the length function. So you can see here, length of names is 4 because there's 4 items in that vector, right? Jimmy, Carl, Eric, Sarah, right? Length does not measure how long a character is. It simply counts how many things are in that vector. So each of these could be really long. It could be like Jimmy likes cats and Carl likes dogs. It could be longer, but the number of elements in the vector isn't going to change. So here it is. So this now, to grab stuff out of the vector, now you have a vector and you want to grab like a particular thing out of the vector. You index it, so, or subset, you know, any kind of synonym for taking out. So this is how you do it in R. This is the syntax. You can use brackets. So if I say names, bracket 1, it's going to give me the first item in that list, Jimmy, or vector, Jimmy. And I can, if I do -1, it gets pets. And so what -1 does, I want everything except the first one. So I do a -sign. All right. And if I want things to do, I want to grab everything after the third limit, then I do 3. And then here's the first time you guys are seeing this. I'm using a function outside of just using the function, but as the output. So if you guys remember, length is 4. So when I run this, it's going to give me 3:4. And what that does is it gives me the third through fourth, but because they're right next to each other, it's just 3 and 4th element. So this little trick here, you'll do that all the time when you're writing your programs. So it's good to know. All right, and that is the basics of R data types. So you learned about numbers, you learned about characters, you learned about logic, and now you learned about vectors. That is the essential data types. Everything else is just those, but bigger. Any questions?
Can I make a comment real quick?
Go, Mufaro, go. Comments.
So indexing in R starts at 1, but I do know that a lot of other programming languages start at 0. Just if you've used other programming languages, I think Python starts at 0. But keep that in mind. It can throw you off a little bit at the beginning if you've programmed before.
Yes. So normally in Python, if you had a vector and you needed the first element, it's 0. But if you do that in R, it won't give you anything. All right. Any last questions? Yes, Natalie got through it off. Yes, Natalie, I remember you saying you're a computer science major. So like I said, R is a statistical coding language, so it has some nuances to it that the statisticians kind of didn't carry from the computer scientists. All right, so next thing, we're going to learn about working with data. And so this is going to be really important. So I'm going to get you guys to take a survey. So we can have data for you to work with, or for me to work with, and you watch me work with it. By the way, all this code will become available to you guys at the end. We'll share it. So there's a Google form. Fill that out as quickly as you can. And then we'll work with this data that you are providing. And so you got an idea of what to work with and how to work with it. So I'll give it a minute or so to do that. They are anonymous surveys, so don't worry. Answer as honestly as you would like. It's a very short survey. All right, we have 12 responses so far. Can we get up to the max, 18? All right, so for the sake of time, we'll keep going. So here I have the Google form that you guys just filled out, and I'm going to download the data as a CSV on my computer. So here it is, Google form downloads as a zip file. I can open up my CSV through Excel to take a look at it. See here, I can see the data in Excel, but we don't want to work on it in Excel. We want to work it in R. We're R users here. So how do we get it into R? Well, first we have to get this file somewhere that our computer can see, R can see. So let me put it in the directory that I'm working in right now. I believe it is not this one. What is R? Let me see here. What is R? What is R? what is our file location? Open file location. All right, give me a second. I got to put it in the right spot. That's here. This is the problem with doing things live. Okay, so what is our, it's in the folder that I'm working in. What is R? So here's where I'm working from. So you can see here in my R studio, what is R? So I'm going to put the data into that folder. There it is, learning R survey. And you can, there it is, learning R survey. So you can get, so there's two ways to tell R where your files are. So you can give it an absolute path. So an absolute path is the file path of where it is, like in relation to your entire directory. So you can see the file here and you can like click on properties. It's different for Mac, but you can see the location of it. And then you know, like that's the absolute location for this file. And so how you give it is you say the absolute location. Fun fact with R doesn't like just one // you need to have two, or // you gotta have two backward slashes or else it's gonna get mad at you. Often new R users, that trips them up. So this is the absolute location of my file, and it is this file, learning R survey, end of quotes. But there's another way to define paths, and that is through a relative path. And so relative paths are really handy. I recommend you know how they work because they'll save you a lot of typing and shenanigans. So you can use this function, get working directory, and that tells you where your relative start is. And so when you're defining a path, so you can see here, users, Victor, no R, what is R, is the same file information here, but it's saved in my working directory. And so this part is unnecessary because I can just define it relatively. And then you can also set your working directory to whatever location you're working from. So normally when you have assignments, you put everything in one folder, I would hope. And then you can just set your working directory to that folder that you're working from. And then you can have a relative path, which would be learning, oh, my caps lock is on, learning rsurvey.csv. And so this path is the same as this path, but it's a relative path because I know I set my working directory to be in this environment. And so this file is a CSV file, if you guys remember from the Excel. And so there's a function in R called read CSV, and I'm going to give it the path.ab variable, right? The absolute path of my file. I'm telling it read CSV at this location, computer. And if I run that, path.ab not found. Oh, I got to run this. Give me a second. Whoop. So here I now have my variables, path.ab, path.rel, absolute path, relative path. And I want to show you guys that it results in the same thing. So I ran read.csv function on the absolute path. It then reads in the data. So here it is. The data is now in R. Great, isn't that cool? Now we can start our analysis. And you can see here, this is the data. And then now you can do the same thing with the relative path, and you get the same results. Relative path, absolute path, it's the same. So really, the best coding practice is to kind of set like the working directory to be a central location. But usually, like beginners will just do the absolute path because it's just easier to quickly type that up. But when you're working on big projects, you want to be able to do relative paths because absolute paths, if you share this code with anybody, they're going to have to change that because they don't have that location on their computer. All right, so we read in the data, right? We can click on here on the environment. This is also a benefit of RStudio is that we can see it here. And right, we can check that it's the same, right? Equal. Yep, true. Yeah, it's all equal. And now I'm going to remove data.ab because it's taking up space in my environment and I don't really want it taking up space in my environment. So Now we're going to get into the examining of data, right? So we can run the dim function, dim. And if you ever don't know what a function does, the syntax that for checking on what a function does is question mark and then the function. And then it's going to show you here in the help tab what that function does, what are the things that go into it. This is very useful. Not many programming languages have this like built in. So our studio is really good for having this kind of really extensive help as you go. So you can see here, it retrieves the dimensions of the object. So you can see here it has 14 rows and 7 columns. Great. And we can check the names. So using the names functions, we can see the names of the variables. Very cool if you don't remember what the names are, which I often don't. So I'll often just be like, what's the names of the data again? And then I'll run that in the command line to then see. Summary, very great function. It does summary descriptive statistics on each of the variables. So you can see here, these are characters, so they don't have any like numeric descriptive. But you can see here, year born, it has the average, the min, the median, first quartile. Same with COVID risk tolerance. Okay, so here, now we're getting to subsetting a data frame. So before we subsetting a vector, and you have the brackets, so similar context here, is data.rel, we give it for one for row and one for column is the kind of formula here for how to subset a data frame. So you can see here, this is going to grab the first 2 rows and the first 3 columns. Boop. And there we go. First 2 rows and the first 3 columns. If you leave it blank, so if you see here, it's like nothing, comma 1, it's going to grab all the rows and the first column. So you can see here, it just gave out a vector of that first column of data. You can pick and choose. So here's C, or I'm using a vector, right? C is for concatenate. I'm going to say 1 and 3 and 1 and 4. And that's going to give me the first and third row and the first and fourth column. So that's kind of how you index data frames and get very complex. But normally you don't really do it like this very often. You can do it by name. This is what you'll be doing all the time, especially this type of notation, data, $, and then the name of the variable. You do that all the time. All the time you do that kind of notation. And that's, see, that gave the same vector for timestamp. And it's a bit more humanly legible, right? You can read this and say, okay, I'm getting this variable from the data versus this, which is like, okay, what's the first column again? So name is usually the preferred way. And you can do it with the brackets instead of the $. You can see it like that, gives the same thing. And here you can see the first, you can combine names and the numbers. Here's the first and third row of timestamp in your born column, or yeah, column. There you go. Great. So those are just a little bit of the basics of indexing. And now subset by condition. This is, you'll be doing this again all the time. Conditioning variables is like the bread and butter of initial analysis. So if we wanted to look at the year born, right? We have the year born, which people were born in 2000. I don't know. So we'll make that, we'll save this into condition. And what that does, what is condition? Let's take a look at it. It's a vector of logic where it checks every single value in the data and asks it, is it equal to 2000? So it checks this off. All right, del. So now we can use this condition in the rows slot to then filter the rows to only look at 2000. Pretty cool. And con.class is, we can look at classification. Say, let's see how many freshmen are here, right? So we get another condition, a logic vector, right? False, 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 false. Oh, there's no freshmen. Let's look at the data. I find that hard to believe. Senior, sophomore. There isn't any. Wow. I would expect a bunch of freshmen. All right. So there we go. No freshmen. So we found that out in the data. That's important information. All right. So now let's go over some plotting. So some graphs. So again, we can look at the data. So beforehand, we've just been clicking on data.rel here and it pulls it up. But if we wanted to do it through code, it would be the view function, capital V. and you run that and it does the same thing. Right, and so now let's do some graphs. Anybody curious into making a bar chart? So bar chart for classification, right? So this would also tell us if there's any freshmen. So in R, where there's a bar plot function, question mark bar plot, and what it takes is a height. It takes a number, a vector number for each of the bars. So we use the table function. So the table function is going to count all the unique character combinations. So if we look at counts, you can see here there's 2 junior, 5 senior, 7 sophomore. A lot of senior here. Let's see here. So then we can now give those counts to the bar plot function here, and we get a bar chart. Junior, senior, sophomore. You see the sophomore majority here. Junior, few, senior, like 5. Right, very cool, very cool. The regular just plot function, let's plot age versus COVID tolerance. Maybe there's a relationship between age and COVID tolerance. Maybe younger people are more prone or more risk prone, or older people are less risk prone. Let's see. Okay, so most people, one person was very risk averse. And then we have most people are 3s, and the one person very not risk averse. So not much going on, very neutral, no pattern here really. But if there was a pattern, we can do a linear regression. So in your stats classes, usually linear regression is the first thing you learn. And in R, the syntax to do a linear regression is with the LM function. And we can do the question mark on it and kind of see how it works. And so it takes a formula, and we haven't talked about formulas, but it's simply a variable and then this kind of tilde and another variable, and then you give it your data. So let's see if we can model risk tolerance from year born. It's probably not going to result in a positive or negative relationship, but who knows? We'll see. lm.fit. Oh, I got to run stuff. I haven't been running things. Wait, data.rel, COVID risk tolerance. Is it not? What is it called? Oh, it has a period at the end. See, that's a little nuance to R, and it can be picky. And so there we go. lmfit was created, and then we can see the summary of lmfit. And you can see here that this isn't the stats class, but you can see it's estimating a negative coefficient, but it is not significant at all, because look at this. You think if you just drew a straight line through this, it's probably just a positive, like 0 coefficient. So that's working with data, with some real data from you guys. All right, any questions so far? All right, we'll move on, power through onto the last section. R packages. So packages is oftentimes a confusing thing to the non-programmer. But what they are simply a family of functions that someone else wrote and you have now access to because they made it publicly available. So if you remember from our R basics section, you can make your own functions. C cubed, that's the function, x cubed. People have written all sorts of functions that do all sorts of things, and they usually package them up and tell you, here you go, I made a package that focuses on this theme, and all the functions inside the package have to do with that. So that's how packages work. And how you install packages in R is you run this kind of command, install.packages, and the name of the packages. Today, we'll be going over dplyr and Ggplot 2 of the more popular packages in R. So you can install them on your computer with install.packages, and then how you kind of get access to them, how you tell R, hey, use these packages, is you call the library function. And so many times you'll see at the beginning of scripts, library calls. You'd be like, okay, here are all the packages I use in my script or in my work. And so you can see here, I've commented it. This is what the green things are. I don't know if I mentioned that, but if you do the pound symbol, then you can just put in dialogue for it. Really important if I come back to this in 2 years and I'm like, what does this do again? So used for manipulating data frames, used for creating graphs. And one way I don't think we covered this, but if you look at data.rel, so I'm using the str function, which stands for structure. You can see like that it's a data frame object. So this is kind of like one of those things. It's like not a numeric, it's not a vector, it's not a logic, it's a mix of things. So as I mentioned, those fundamental things we talked about in our basics, everything is just like a bigger, more different combination of those stuff. So data frame is an example of that. So we're going to use dplyr. Yes, there is a library function. Yeah, you don't want to have all your packages like loaded up all at once. It'd be very confusing. So using dplyr. So first, let's get some data. So we're going to forgo the survey data in interest of the iris data. So I'm going to clear my environment here to serve for the start of the script. So I just press a little broom to clean up my variables. And I'm going to load this command here, iris. So iris dataset is one of the data sets that's just built into R. So it has its own little command and it'll just summon the data like that. And so we're going to save it as data frame, the df, which is popular notation for that type of variable. And you can see here, we can look at it. It has these variables, has that many rows, things like that. It's a very popular data set for learning. So we can filter data. So as I showed before, working with data, right? I showed the conditions for it. And so with base R, you can see here data f $ species. So that's that species vector. So that's this, right? I can show it off here. Right, it's the vector, and then we're going to say equal to right to Setosa, and that's going to filter it. So only the Setosa variables are there. Only the species of that type is there. And so dplyr, this package is used for manipulating data, and it has its own way of doing it called the filter function. And this is how the syntax to do it in the filter function is you just give it the data and you give it the condition. And then you run it, does the same exact thing. The only difference is the notation of it. And usually people will go with dplyr because it's just more like humanly legible. So if you look at this, if you're not familiar with like R syntax, then this might be more confusing to you. Like, what the heck's going on here? But in this, it's very humanly legible. I'm filtering based on that condition. This data on that condition. Very humanly legible. That's why dplyr is very popular. So selecting variables. So this is when you want to look at a particular set of variables. So here's how you do it in base R is you just say all the rows and then you give it the named list. We've done it before. And you can see here, it's the two variables we want. In dplyr, you just use the select function and it does the same exact thing, but just maybe a little bit more humanly legible, maybe a bit easier to write. All right, adding new variables to a data set. So here is how you add a new variable is you say the old vector multiply, this is the formula I'm doing. You could do anything here. You could do like dog and it's going to make that entire vector dog. But I'm calculating the sepal area with the length times the width. And so we do that. And then if we look at it, we can see here sepal area and it has that the new numbers, which is the area of the sepal width times sepal length. All right, and dplyr, if you wanted to do this, you would use the mutate function. Mutate functions used all the time for when you're manipulating data. You use it all the time. And so this would be the syntax for it. You give it the data, and then you tell it your new variable, and you say it's equal to. Notice the single equal to, not the two equal. It's just one because you're not comparing. You're saying this is equal. You're not asking a question. Is equal to that. And then that does, of course, the same exact thing. And then you save it. You can overwrite itself. All right. But one thing, maybe you guys are thinking like, oh, it's all just tedious. It's all just what reads better, what doesn't read better. Dplyr has the support of the powerful pipe. And the pipe can be quite confusing if you haven't known it before. But how it works is it simply passes the output of a function into a new function. It just transfers the output out. And the pipe, a little bit of history, comes to the Magitar package, but because it's so popular, they include it in other packages, like dplyr. So here, if I wanted to do base R no pipe, work. And I wanted to create sepal area, and I wanted to filter the data, and I wanted to select certain columns, and then I wanted to do a pairs plot. This would be how I would do it. And I get the pairs plot. And this is the code to do that, is to make my new column, filter it on Satosa, and then select only the columns I'm interested in. And I run the pairs function, which produces this plot. The dplyr pipe method is very interesting because I use df, I get my data, I use the pipe, and then the pipe goes to the data goes to the mutate function, and then does the mutation, the adding of the new column. And then okay, now take that, take it to the filter function, filter it. Okay, now take that, go to the select function, select it, these variables, then take that to the pairs function. And so this usually is what people really like about those various functions, is support for the pipe. To do the pipe with this process would not be as friendly. It'd be very kind of hard because you're doing all these assignments intermediately, whereas in the pipe, it does it subconsciously. And they do the same exact thing. If I run this, same result, the plot did not change. I'm touching these two errors, the same thing. So it's really up to you on what you prefer. Generally, people like pipes, but a lot of the old school R users are just more familiar with the base R. But this is the way I use this all the time. So now about Ggplot. So I'm running low on time. So Ggplot is a very complex package, or not complex, but it can be complex. But you'll often see it in your courses. But it's a way to plot things, particularly complex plots. Usually for simple, quick plots that you just want to get information out of, it's usually just easier to stick with base R, require less typing. So for example, if I want to do a scatter plot of the sepia length versus sepia width, I just use the plot function, and then boop, it makes a little scatter plot. Awesome. If it's to use Ggplot, it uses the Ggplot function, and I have to give it the data, and then I set a mapping where I say x is equal to this, y is equal to this, and then I add a geom point, which then makes a scatter plot. It makes a nicer looking scatter plot, and that's why people like Ggplot, is it makes nice plots. But if you were just interested on like answering a question for a quiz, this might be an easier way to type that up than to do with this. Same with the box plot. So here's a box plot. I can see the area by distance or by species, use the box plot function. In Ggplot, it's the same Ggplot mapping. You tell it your X, you tell it your Y, and then you use geom box plot. And you get a box plot too. Same box plot, just looks different. But for a more complex scatter plot is really where Ggplot shines, is when you have these complex plots. So here in base R, we're going to make a plot that's colored by species. And so here's and then has a legend here. So you can see here black, you can see green and red. Each of these is its own plant. In Ggplot, it's a bit more humanly legible about what's going on. And it looks nicer too. So for more complex plots is really when Ggplot shines in contrast to the regular plot functionality in R. And a fun fact, if you need to use a function from a package and you don't want to load the entire package, you can just call it like this. You can say dplyr : the function name, and then use the function. That can be handy from time to time. All right, we're getting to the end of the time. This was all the required material I wanted to cover. Any questions? I wanted to show one thing that I thought was cool, is something I made for my internship using R. While we have a last minute here. So I made a Shiny app. This is just to show something like very complex to do in R, but it's done 100% R. You can see all the code. It's confusing, but I can run this app and get a web application that's done in R. And so this is really what's cool, and what sells the skill of learning R is being able to do stuff like this. Is you can filter data. Yeah, everyone can filter data and work with data, but it's making something really cool and interactive and analyzing data that's really nice and neat. So this is something I did in my internship. But yeah, oh wait, actually I have one more slide to cover. I know we're right at the clock. let's see here. Screen two. What the heck is R? All right, so learning more. You want to learn more about R. You watched this presentation and it was amazing and you loved it. You want to learn more. Here are some links. So for you guys, I'll put them in the chat. But that is the R for Data Science book. Really good. It kind of talked about what I just talked about, but in a lot more depth and I think easier to read. Introduction to Statistical Learning. So if you're maybe not, you're not taking like classes with it and you're just like kind of passionate about it yourself, or you want to really develop like an advanced skill to put on your resume, learn a little bit more about modeling. This book is one of the best out there for modeling. There's LinkedIn Learning, which is a resource we have at UTSA. It has a bunch of videos to cover content. You can also get like DataCamp for free with GitHub, Student Pack. I like DataCamp. It's nice. And but it costs money. So I just use it for the 3 months free and I haven't used it since. And you can also check out a bunch of books on the O'Reilly learning site. We have access to that as well through UTSA. So with those resources and your classes, and like if you want to become an R master, like this is enough to do it. And then time. It takes a lot of time and effort to become like fluent. I've been working in R for like a year, a little bit more than a year, and like I get it now, but like at the beginning, it's like super confusing, and like what do I do? How does things work? It's so hard, but it takes time. It takes time. So any last remarks? So Natalie, you're asking, is it important to be familiar with R for someone trying to get into the data science field? Yes, Andrea, I will do that. So Natalie, it really depends. So if you are working at a company where say the analysts are using R, then it's going to be beneficial for you to learn at least the basics of R so that you can kind of cross communicate, right? But usually if it depends on the field and the type of data science, so R is really used for a lot of kind of analyst research questions. So like we have data, trying to answer a question. It's not particularly used for like, it can be used and there's packages to use it, but the everyday R user doesn't. It doesn't like tie it into other applications. For example, if you wanted to make a phone app that takes advantage of machine learning algorithms, and when you take a picture of your face, it's going to tell you who you are. That's going to be a way better use for Python, because Python is a more general purpose language to interact with other systems. R is more like you're trying to do an analysis, you're trying to answer this question, and it really depends on the company on whether or not they're using R or not using R. But definitely at least be familiar with it, but by no means like you probably don't need to be an expert. If you're an expert in one of those things like Python or things, but R has a lot of data science tools actually that still Python doesn't have yet. Some modeling techniques that, for example, like multi-level modeling or like some of the Bayesian modeling, more of the like really advanced stuff, Python still doesn't have. R has though. And if you're interested in biology, R has a lot of support in biology because of the bioconductor. It sounds really cool. But the bioconductor is a family of packages that people have written to work with biological data, and it is heavily used in the biology field. And so this is one of the reasons why like R is really heavily used in biology, but people are, getting more exposed to Python as well. So, but yeah, this is probably at least for the past next several years, like the bioconductor is going to be what keeps people still using R in the biology field. Yes, we'll have it on our YouTube channel, Kathleen, and we'll put it on. We'll send an email out when that's uploaded. So yeah, any last questions, guys? Any concerns?
I put the link to our channel, so it'll be there once it's
Yeah.
uploaded.
You can subscribe, Kathleen.
Yeah, please do. We got like 7 subscribers right now, so let's get us to 10. But if there aren't any other questions, thanks, Victor, for hosting this session. It was really good. I haven't used R in a couple months, so it's a nice refresher going into the semester, definitely. I'll stop recording the session so it's not a bit too long, but I think we should get like a good 55 minutes.
Yeah.